It's a pleasure, really, for me to introduce Debra, which I will do in a moment. But first, I would like to take the opportunity, for those of you who are not aware of the Chicago Council on Science and Technology, to say just a few words about what we're all about. We are a recent organization, a little less than 3 years old, and our mission is to raise the awareness of the critical importance of science and technology in our society. Issues that you get your information from the newspaper, which are probably incorrect, on issues, stem cells, nuclear power, global warming, and we are fully capable of providing lectures by people who actually know something about the subject. We are an organization that has on the board all of the important science and technology generating organizations in the Chicagoland area. The universities, the national laboratories, the museums, some of our industries, and they're all quite active. So I encourage you to join the organization. We are a membership organization. We have a number of quite interesting programs coming up. We've had a number of interesting programs that we have had. Our next one is the one on stem cells and nanotechnology. A couple of very important professors in Chicago, Jack Kessler, professor of stem cell biology, and Samuel Stoop, who's professor of material science, both at Northwestern. And the combination of nanotechnology and stem cell advances promises to provide a real impact on medicine. So that's our next one. One after that is Paul Serino. You probably all know Paul. There's a movie When Crocs Ate Dinosaurs. So I encourage you to come to that. Bring your friends, and of course bring the younger people. Next year we have a series of programs, one on this very interesting issue of women in science. The issue of a lot of women take science courses, but there's a real drop-off when it comes to women continuing their career in science. There's a program that our manager of the organization, Erin Dragotto, sitting over there, talking and not listening to me, is managing. Then we have one on the critical issue of how do we deal with global warming. We have a scientist from Northwestern University on the where do we stand in solar. We have a scientist from Argonne National Laboratory on what are the critical issues in battery technology. And we have a scientist from IIT who will talk about the electrical grid. So it'll be a very interesting panel. These are just a few of the meetings that we have that deal with this critical issue of the impact of science and technology on our society. Obviously, we would like to provide the background so people become informed voters. I joined the organization. We have special rates for teachers and students. And with that, I would like to introduce the speaker, Debra Shore, who is the commissioner of the Metropolitan Water Reclamation District, going to talk about this really critical issue of water, which is becoming the new oil. And Debra has a bachelor's degree from Goucher College, actually, Phi Beta Kappa, Master of Liberal Arts from Johns Hopkins, Master of Fine Arts in Creative Writing from Columbia College, awarded Certificate of Completion of Senior Executive in State and Local Government. I see a little-known fact is that she's climbed 42 of the 54 mountains in Colorado that are over 14,000 feet high. It's a real accomplishment. She's a leader in the Regional Conservation Consortium known as Chicago Wilderness, more than 200 public and private organizations and that work together to protect, preserve, restore, and manage the ecosystem of the greater Chicago metropolitan area. Debra was a founding editor of Chicago Wilderness magazine. It's an award-winning quarterly devoted to the rare nature of the Chicago region. I could go on, but you'll find this little brochure outside, and I recommend it to your attention. And finally, you will find these cards, which I would love to have you fill out. They're these audience satisfaction cards that enable us to get a feel for what you think of each individual program and how we can modify those for maximum effect. Well, I have carried on too long, and this is the last you're going to hear from me. And Debra.
Thank you. Thank you for inviting me here this evening. I'm delighted to be here. Can you all hear me? I'm going to roam around the landscape a little bit with you tonight and talk about water, starting out globally and then kind of reaching the shores of a very great lake. You know, water was here before we were, and in all likelihood, water will be here after us, but we could not be here at all without water. And if you look up the 3 essential ingredients for life on Earth, the first and foremost is liquid water. And it's been noted that if you end the oil supply, the motor stops. But if you end the water supply, life stops. And I want to ask your indulgence and read 2 paragraphs from an article that appeared in the New Yorker several years ago called The Last Drop. And in it, the author, Michael Spector, wrote, "Philosophers and economists, at least since Copernicus, have noted that although no substance is more valuable than water, none is more likely to be free. In The Wealth of Nations, Adam Smith called this the diamond water paradox. Although water is essential for life and the value of diamonds is mostly aesthetic, the price of water has always been far lower than that of diamonds. Economists often argue that water should be considered a commodity, like housing or food. But water possesses an intangible, even mystical quality that transcends the principles of economics. People simply don't think about it in the way that they think about transportation or clothing, and they never have. Water is precious, but not like oil, which once burned is gone forever. While there is almost no human activity that doesn't depend on water in some way, it never actually disappears. When water leaves one place, it simply goes somewhere else. Water that dinosaurs drank is still consumed by humans. Think about that. Water that dinosaurs drank is still consumed by humans, and the amount of fresh water on Earth has not changed significantly for millions of years. But that doesn't mean it's available when or where it's needed. Nearly all of the Earth's water is in the ocean. Only 3% is even theoretically available for humans to drink. Most of that is locked in polar ice caps and glaciers or deeply embedded in layers of rock. If a large bucket were to represent all the seawater on the planet, and a coffee cup, the amount of fresh water frozen in glaciers, only a teaspoon would remain for us to drink. And of that teaspoon, nearly 20% is in the Great Lakes. So that's the end of my quoting from Michael Spector. So let's take a look out the window, in effect, at water in the Chicago region. And you may have a handout that was passed around. If you don't, we'll get you one, that shows this map. Joel Greenberg has noted in his Natural History of the Chicago region, quote, "The force of the glacier ordained that the Chicago region would straddle the eastern continental divide, separating the drainage area of the Atlantic Ocean from that of the Gulf of Mexico. The Des Plaines River, the Fox River, the Kankakee River, and their tributaries lie in the Illinois and Mississippi watershed. The Chicago River and the Calumet flowed into the Great Lakes." So what this map shows, this wavy line, is this eastern continental divide, just the highest point on the landscape left by the retreat of the last glacier, which at one time, 14,000 years ago, we were under a half mile or more of ice. As that glacier retreated, it scoured the landscape. It left an enormously rich mix of soils. It left these glacial ridges and moraines. It left giant ice cubes that, as they melted, created prairie potholes. It left a very great lake. And so this was the landscape that the settlers from the east came upon, and all the rain that falls on this part of the landscape on the east side of this divide would make its way into the rivers and streams and replenish Lake Michigan. All the rain falling on the west side would make its way into the rivers and streams, into the Des Plaines, which flows into the Illinois, which flows into the Mississippi, and ends up in the Gulf of Mexico. So decisions made and engineering projects undertaken more than a century ago shape our water use and define our region. Chicago is a city in a garden, for sure, but it's also the city that reversed a river. And from that endeavor, all else flows. And what you see in these maps, these sort of smudges here at the lake, are contaminated water. You had a city where industry was booming. The Union stockyards opened in 1865. People were dumping all manner of human and animal waste and other pollutants into the Chicago River, which flowed into Lake Michigan, which was the source of their drinking water. And they kept trying to move the intake pipes further out, but storms would swirl this contaminated water out towards the pipes. Waterborne illnesses like cholera, typhoid fever, and dysentery caused many deaths. And the municipal water treatment didn't come around till the 1930s. But we're talking about the 1860s, 1870s. And so this was a serious problem, limiting Chicago's growth, a real public health challenge. Well, it's been said that all problems started out as solutions. I want you to remember that. The solution to the problem of Chicago's contaminated drinking water was to construct two major channels, connecting the Chicago River to the Des Plaines River, building a lock at the mouth of the Chicago River, and using water from Lake Michigan to flush our sewage and our polluted water downstream. And this just shows the situation as it was then. This was the early lakefront at the time. So, and this shows the sanitary district dug a 28-mile sanitary ship canal It took 11 years between 1889 and 1900 and built a lock near Lake Michigan and at Lockport and diverted the flow of the North Branch, the South Branch, and the main stem into the canal and to the Des Plaines River. And completion of the 8-mile North Shore Channel in 1910 diverted wastes from the northern suburbs from Lake Michigan into the North Branch. And so this just shows how they broke through that natural barrier, that eastern continental divide, and used lake water to flush our sewage downstream so it would be someone else's problem. And so this is what the system looked like after the canals were built. You had the main channel, the sanitary ship canal, the Calsag Channel, and in 1910 the North Shore Channel. And no longer do you see any contaminated water in the lake. It saved the city, and I would submit allowed Chicago to become a booming metropolis. But mind you, these massive engineering projects were essentially open sewage pipes to convey human and animal waste downstream. They were man-made channels, dug where no waterways had existed previously. And what a fantastic demonstration of human agency. We reversed a river and saved a city. What a testament to our ingenuity, gumption, drive, and determination. Environmentalist Roland Clement has said, "Our whole society was built on the notion that we could and must control nature, that we must master our circumstances technologically. But natural systems are the consequence of a long evolution, and ecology is teaching us that we must first understand these systems to see how far we may modify them for our own benefit without disastrous consequences. This is a new point of view that arose with ecological science, that world systems have a functional reality of their own, and that if we push them too far, the systems will either break down or backfire." By the 1920s, more modern techniques of sewage treatment were developed, and the agency that was formed in 1889, called the Chicago Sanitary District, built 7 wastewater treatment plants around Cook County, including what's considered the world's largest at Stickney. So we no longer send raw sewage downstream. Now we convey our wastes to these treatment plants, but the treated wastewater, called effluent, is still discharged into the canals. The plants are located along them. And the effluent ultimately ends up in the Gulf of Mexico. Today, 70% of the flow in the Chicago area waterways is from the discharge of treated wastewater coming from the district's treatment plants. And so these are considered effluent-dominated waterways. And I'll come back to why that's important. So remember when I said that all problems started out as solutions? By reversing the Chicago River, by solving the problem of Chicago's contaminated drinking water, we created in turn at least 2 new problems. First, we made a conduit between the Illinois and Mississippi River and the Great Lakes that did not exist in nature. So that today we're spending millions of dollars to try to prevent invasive species such as the Asian carp from traveling up the Mississippi and Illinois rivers and entering the Great Lakes, where it is likely that they will decimate the sport fishery. And we broke the natural hydrologic cycle. So on the other side of that sheet you see a map with this sort of kidney bean shape around Lake Michigan. We created what's known as the Chicago diversion. Today, we take close to 1 billion gallons of water a day from Lake Michigan for residential and industrial use, and we return almost none of it. And all the rain that falls on the landscape east of the Continental Divide still makes its way into the Chicago River and its tributaries, but now that flow no longer replenishes the lake. It ends up in the Gulf of Mexico. And so this map shows what's called the diverted portion of the Lake Michigan watershed. That's the portion of the landscape on which the rain falls but no longer makes its way back into Lake Michigan. Since 1967, the Illinois diversion has resulted in about 30 trillion gallons, or 27 cubic miles of water taken out of Lake Michigan. We take water, this precious liquid asset, out of the lake. We essentially use it once, and then we throw it away. No wonder we call it wastewater. And I ask you, how smart is that? How smart is it to treat the substance on which virtually all life depends as if it was garbage? And this shows what remains of the Lake Michigan watershed, just a very narrow strip in northeast Illinois, where the rain falling on that part of the landscape will still make its way into Lake Michigan. Chicago and 50 of the other older communities in Cook County have what are known as combined sewer systems, in which human waste gets mixed with stormwater flowing into the sewer pipes. At times, the amount of combined stormwater and sewage exceeds the capacity of these pipes, and overflows containing raw sewage will dump into Chicago's rivers and streams. As a result, in the late 1960s, the Tunnel and Reservoir Plan was conceived to reduce and nearly eliminate the release of untreated water to streams, to Lake Michigan, and to people's basements. The tunnel portion, commonly known as Deep Tunnel, was completed in May 2006. It's 109 miles of underground storage, burrowed in the deep bedrock limestone 300 feet below the surface, largely underneath the Chicago River, and there are two other sections. This system, essentially an underground storage tank, can hold up to 2.5 billion gallons of combined sewer overflow, which is then pumped to the treatment plants when they have the capacity, and the water is treated before it's discharged into the waterways. But the system was conceived as a tunnel and reservoir plan, so there are 3 reservoirs that are part of this. One of them near O'Hare has been completed, and 2 others in Thornton and McCook are due to be completed in 2014 and 2023. And when the entire system is finished, they should have the capacity to capture 17 billion gallons of stormwater overflow, and we hope eliminate almost all of the combined sewer overflows into our waterways. This system has dramatically reduced flooding, but some big storms, such as the historically huge one we experienced in September 2008, require the Water Reclamation District to open the gates at the locks and at Wilmette Harbor and release untreated sewage diluted by stormwater into the lake. Today, approximately 42% of Cook County is impervious surface. We have built and paved and covered over the landscape. So it's no wonder that during storms, water has no place to go. And I want to talk a little bit about things I'm seeing happening in our communities. I happen to live in Skokie, and this is on my block, and some of you may see this happening in your communities, where an older home on the top, built in the 1950s, was torn down and replaced with a newer, larger structure. And so the footprint of the newer home, the amount of impervious surface, is larger than the older one. And this diagram shows that footprint on the landscape. Well, that build-out from that single parcel results in 50,000 more gallons a year of stormwater runoff from that one lot. And there are 4 such teardowns on my block. And that 50,000 gallons isn't spread out equally over the course of a year. It's during rainstorms, where that water is running into the street, into the same pipe running below the street that was laid in the 1950s that carries waste from our homes and the storm water going in through the street drains. So that's 200,000 more gallons from those 4 parcels into that same size pipe. And as you know, pipes can only hold so much water. So it's no surprise that we get basement backups or street flooding and things like that. And that just shows the increase in the runoff. These are some images we got from Des Plaines, where you see over the last 60 years the build-out on the landscape, the exact same parcels then and now. Des Plaines is 48% impervious surface. And you see what's happening there. And this was taken during the big storm in September of 2008. So this is where I live, a rather modest single-family home in Skokie with a rather large asphalt driveway. And my partner and I wanted to rip it up and replace it with gravel or another impermeable surface so that rainwater could infiltrate and recharge our underground water supply. And there's a formula called the runoff coefficient, where you can measure the surface area of a roof or a driveway or a sidewalk, and you calculate the annual rainfall, and it tells you how much is running off of that surface. So we calculated that if we converted our driveway to gravel, it would save between 9,000 and 10,000 gallons a year that today runs into the street, collects salt and oil and contaminants, goes into the sewers. We then pay to treat it, and then we send it to the Gulf of Mexico. Now, how sustainable is that? And so I was struggling for how to show what does 10,000 gallons a year look like? And this is what it looks like. So over 3 years, from that one driveway, that's what flows off. That is falling from the sky is essentially fresh water. And because we have these combined sewers, we instantly convert it into contaminated water when it goes into the street. Well, the village of Skokie said to us, no, you can't use gravel. You can only use asphalt, concrete, or paving brick, all of which are impervious surfaces. And we pushed them a little bit, and they said, well, you can do it as an exception, but they haven't changed the ordinance. And I feel that we, at a minimum, shouldn't put impediments in people's way if they want to do the right thing, but could try to find incentives for them to do that. So what do we do? This is just an image of what it could look like if you convert to some kind of permeable surface. And it doesn't have to be gravel. So there's a whole suite of techniques called green infrastructure that are ways to capture rainwater where it falls and allow it to recharge our underground aquifers, to evaporate, to keep it in the natural hydrologic cycle, to be taken up by plants. What's the #1 irrigated crop in America? It's the American lawn. And we get to ask, well, what does it produce? So we can liberate parts of our lawns using native plants which don't require mowing, don't require watering, which have deep root systems that act as a carbon capture system and as a water capture system, and also provide habitat for beneficial insects and so on. You see here a rain barrel like the ones that our agency, the Water Reclamation District, sells, and much more attractively decorated ones outside. These, we are selling them for $40 a piece. It's a bargain. And you attach it to the downspout of your home. It captures the rain coming off of your roof. You can use that to water your lawn, to wash your car. So it's as a dual good. It's slowing the flow of stormwater into the storm drains. You're saving that much potable water instead of using that to irrigate your lawn. And eventually it'll pay for itself. They come with a spigot. You can attach a hose, and they have a mesh top to prevent mosquitoes from getting in. They're a wonderful tool, and sometimes people connect more than one because the water comes off a roof pretty quickly. These are called bioswales, essentially a vegetated ditch along the side of a road with plants that can take up water and allow it to evaporate. A larger kind of bioswale, the famous green roof on the roof of Chicago City Hall, again, slows the flow of rainwater into the storm drains, cools the building, is habitat for birds and bees. They even have a beehive on the roof, and essentially takes that built footprint of the ground and moves it up to roof level. So this brings me to at least one issue that we at the Water Reclamation District are facing that involves the intersection of science and policy, and it concerns disinfection. The Water Reclamation District's 3 largest plants treat close to 1.5 billion gallons a day of wastewater, discharging the effluent into the Cowsag Channel, the Sanitary and Ship Canal, and the North Shore Channel. This effluent contains bacteria, viruses, and other pathogens. But because we send this wastewater into the canals, these man-made waterways, and don't return it to the lake, which is the source of our drinking water, the district is not required to disinfect or kill all the bacteria. In the fall of 2007, after many years of study and review, the Illinois Environmental Protection Agency proposed new water quality standards for the Chicago area waterways. Under the mandate of the Federal Clean Water Act, the Illinois EPA conducted what is called a use attainability analysis, reviewing the conditions of the waterways and trying to determine what is the highest attainable use for these streams, rivers, and channels. Were they suitable for fishing, for canoeing and kayaking, for swimming? Were they so polluted by industry that they were only suitable for commercial barge traffic and pleasure boating? And the Illinois EPA's conclusion was that certain stretches of the Chicago area waterways were suitable for recreational contact, for activities such as boating and fishing and canoeing and kayaking that might cause someone to have some contact with the water, to be splashed or ingest droplets or spray, but not to be immersed in the water, as in swimming or full-body contact. So the Illinois EPA proposed new higher standards for dischargers to the waterways. These new proposed standards, which are now the subject of extended hearings going on more than 2 years before the Illinois Pollution Control Board, would require disinfection of the effluent from the Water Reclamation District's Stickney, Calumet, and Northside plants. Unlike water quality standards for dissolved oxygen and temperature, which affect aquatic life and habitat, the bacterial standards are set principally to protect human health. And this is where I got stuck as somebody charged with making public policy. You can know, and I suspect you may share this with me, we know intuitively that it's not a good idea to send people to play in what my friend Henry Henderson calls potty water, to recreate in water that has high levels of fecal coliform bacteria in it. And so then you ask, well, why is it not a good idea? And and people say, well, people might get sick. And so then you ask the follow-up question, well, are they getting sick? And the answer is we don't know. We don't know if people are getting sick from recreational contact with these effluent-dominated waterways, and in what numbers, if they are. As someone charged with stewardship of finite public resources, namely our tax dollars, I have to ask, should we spend close to $500 million, because that's what the cost estimates are, to disinfect the effluent if we don't know the health benefits of doing so? Remember, our wastewater flows downstream, not into our drinking water supply. These pathogens in the effluent die or settle out or degrade by the time they travel a few miles downstream, so they do not pose a threat to any other city's drinking water supply either. To attempt to answer the question, the Water Reclamation District has commissioned an $8 million epidemiological study that's being conducted by the UIC School of Public Health. For 3 years now, during the recreational season, from May to the beginning of November, researchers have been recruiting participants in 3 groups. Those who canoe, kayak, row, fish, and go boating in the Chicago area waterways, those who participate in those activities on Lake Michigan, and those whose outdoor recreation doesn't involve water contact, like joggers, cyclists, or tennis players. The research team is also conducting a separate swimming pool study to measure the amount of water people swallow when they participate in outdoor activities on or near water. The recreation study has recruited some 10,000 participants, and we hope to have results sometime early next year. And by the way, if you have specific questions, the study is called CHEERS, which stands for Chicago Health, Environmental Exposure, and Recreation Study, and Dr. Sam Dorovich at UIC is the principal investigator. Obviously, if this research shows that recreational users of the Chicago area waterways are getting sick in statistically significant numbers, then the argument to compel disinfection of the district's effluent becomes much clearer. But what if the study is inconclusive? As you can imagine, this is a tough kind of study to do. How do you know whether somebody gets sick from incidental contact with the waterways when they were rowing crew, or from the salad they ate at lunch and the spinach has E. coli on it? And the study is designed to take stool samples for if anybody gets sick to report in, but it's a tough kind of study. As I understand it, the Clean Water Act basically says if you can attain this use, then you must do so. It doesn't say only if you can afford to do so. It doesn't say only if there's widespread public support for you to do so. It says if this river can be made safe for boating and fishing, that's what you must do. And it's a totally admirable goal and has resulted in much cleaner waterways in the U.S. in the last 35 years. In my heart, I want to support disinfection because I believe it's the right thing to do, but I was struggling to make the argument. I didn't have the science to back me up. So I asked a young project assistant of mine named David Reese to look at this question from another angle. I said, let's apply the precautionary principle as a filter through which to review the issue of disinfection. And David's paper is posted on my website, which is debrashore.org, if you're interested in reading a really thorough and somewhat dense analysis. The precautionary principle, to those of you who haven't heard of it, is a decision-making framework holding that a lack of scientific certainty should not be used to delay action to address potential harms. I've already outlined the potential harm to people recreating in water that has fecal indicator bacteria in it. In addition, children, pregnant women, the elderly, and immunocompromised persons face a disproportionate risk of infection during recreation. And moreover, disinfection advocates warn that this elevated risk may go undetected by the epidemiological study because of the research team's inability to survey statistically sufficient samples of these subpopulations. Furthermore, human fecal pathogens in effluent may pose a risk to aquatic mammals like otters, beavers, and muskrats, all of which are known to be in the Chicago waterways. However, adopting the precautionary principle as a decision-making filter means we must consider not only target risks, but also risks that may result from any actions taken to reduce target risks. In other words, a precautionary consideration of disinfection must pay close attention to the potential harms associated with disinfection. Here's what I mean. The likely method that our agency would use to disinfect our effluent is to expose it to ultraviolet light. Ultraviolet light consumes a lot of energy. We're talking about huge amounts of water here. And that energy produces greenhouse gases, and the UV bulbs contain mercury. A study conducted for the Water Reclamation District predicts that disinfection would lead to the annual emission of 180 tons of nitrogen oxides and 650 tons of sulfur oxides, both respiratory irritants linked to lung damage and premature death, as well as 6 pounds of mercury, which is toxic to people and animals and impairs neurological development in children and fetuses. And this brings us to the issues of risk distribution and environmental justice, because Chicago's 2 coal-burning power plants represent a substantial involuntary risk to residents of predominantly Latino neighborhoods, the Fisk plant in Pilsen and the Crawford plant in Little Village, where, according to a 2001 study by the Harvard School of Public Health, they cause 41 premature deaths, 2,800 asthma attacks, and 500 emergency room visits a year. Moreover, mercury bioaccumulates in aquatic food chains, therefore posing a significant risk to aquatic predators like otters and humans as well. So how do we weigh the reduction of risk to recreational users of the Chicago waterways, which is largely a voluntary activity? Not totally. There are barge captains and boaters working on the waterways, but mostly recreational use is voluntary, against the damage to the environment from coal plants and greenhouse gas emissions spread unevenly and involuntarily across communities and the globe. David's nuanced and careful analysis concluded that the cost to the environment and to human health from the increased energy use and the moral imperative of distributive justice outweigh the potential benefits of disinfection to recreational users of the Chicago area waterway system. So what do we do? And at the end of the day, is there not also a moral question we must ask as well? And that is, what do we owe the river? 120 years ago, in part because it was the cheapest alternative, we reversed a river and saved a city. We dug miles of canals to convey sewage downstream and to carry barge traffic on inland waterways to a bustling urban center. No one ever imagined that one day people would canoe or kayak on these waterways. No one envisioned that these open sewer pipes could become a treasured part of a vibrant metropolis for the 21st century, that the number of fish species would increase, that endangered black-crowned night herons would make a home here, that people would no longer turn their backs to the river, but see it as an amenity and an attraction. The river has been called the artery running through the heart of the city. Do we have the vision, the will, and the wherewithal to clean up this urban working river, making it safer for recreation, healthier, and more beautiful? This is not a simple question. It will cost a lot of money. And yet, are we not diminished as a people if we continue to treat our water as a waste product and our rivers as a garbage dump? So we ask, what are our obligations to our human neighbors, to our children, to the rest of nature? And so this is the policy debate facing us collectively. What do we want for our waterways, and at what cost? So thank you very much.
I think we'll open it up for questions if you have questions.
I'm happy to take questions. I'm also happy to discuss a few other issues that our agency is facing that may be of interest to you. One that I'm trying to work on is the issue of pharmaceutical disposal, and another is reuse of our effluent. But let's go to questions first.
We're recording,
I
so we
won't
just
hear
want to
you,
keep
but-
it.
On the map of the Chicago diversion that you showed, I noticed that presumably starting around Evanston or maybe Wilmette, there's that white strip along the lake, and I wondered, is that what accounts for that excluded area? Was it just North Shore towns that didn't go along with the plan? Is that Ridge Avenue? It's
Ridge Avenue. It's a sub-watershed that, because of Ridge Avenue, it will still make its way to the lake.
Great, thanks.
Oh, question.
I kind of have two questions. You described effluent as treated wastewater. Is that correct? But then you are discussing, the disinfecting of effluent. So can you maybe describe those terms more closely, like treated versus disinfected? And then also, do other cities disinfect their effluent, and how do they do that?
So let me start with the second question is, do other cities disinfect their effluent? And the answer is yes, almost all major cities in the U.S. do. There are a few that discharge their wastewater either to the ocean or St. Louis to the Mississippi River, which is not suitable for recreational contact. So they are not required to disinfect, though the federal EPA is attempting to move those cities to do so. And then the question was about the treated effluent versus disinfected effluent. By treated, I mean at the treatment plants, we separate the liquid waste from the solid waste. The solid waste, which used to be called sludge, now is called biosolids. And that's used as a daily cover on landfill or for a soil amendment in some agricultural uses. And Milwaukee, for many years, has produced a kind of fertilizer called Milorganite, and it's sold from their solid waste. So the process of separating that solid waste from liquid waste involves killing some of the bacteria, and there are bugs in the treatment process that eat some stuff. But there still is a high amount of bacteria, viruses, and pathogens in the water that goes through the plants and then is dumped into the rivers. One of the arguments that some in our agency are making is that we are not the only source of bacteria in the waterways. There is runoff that contains animal waste and from some human waste from broken sewer pipes that gets into the rivers and streams from stormwater runoff. So even if we kill much of the bacteria through adding this additional step called disinfection, it won't remove all the bacteria in our waterways. It also won't make them smell better or look better. Those are other issues. But it might make them safer for recreational use. And I have to tell you, I came into office 3 years ago and remain an ardent conservationist. And The conservation community was my foremost base, and I royally pissed them off, to my regret, by asking these questions about using the precautionary principle and asking questions. The Clean Water Act doesn't allow you to say, if we had several $100 million to use to clean up our and restore our Chicago waterways, what's the best way to do that? And how might we use those funds? It might be in restoring habitat along the waterways. But that federal law doesn't allow us to ask that question, nor does it allow you to use the Clean Air Act, which is concerned with air quality, as a cudgel to beat up on the Clean Water Act. So it's been an interesting educational journey for me.
So the question then is, how do we incentivize people to use things like those rain barrels, or even installing cisterns in their houses when they have those large footprint houses and things like that? I mean, that seems like the first step. And then the second step is, like you're saying, instead of putting something that has asphalt, using concrete that's porous, or using, you know, even bricks that aren't that don't have mortar in them. I mean, how do we get, we were just talking about that outside, is how do we motivate people to think in a sustainable fashion, even when they're constructing their buildings, so that it's essentially efficient?
So the question is, how do we promote those green infrastructure techniques? How do we motivate people to act in a sustainable way? We have found the sale of rain barrels to be very popular. People are getting it. But I think we need policies in place that provide incentives to do the right thing and disincentives not to. You know, can we, in effect, peel back part of that concrete skin that we've laid over the landscape? Think of all the church and school parking lots that may only be used 2 or 3 times a week that could be resurfaced with a permeable kind of asphalt. And there are great strides being made now in the development of such things. If you have a chance to go to Cellular Field, check out Lot F, which is now or was the largest permeable parking lot in the country. The Illinois Sports Facilities Authority installed some permeable paving brick that can sequester 1 million gallons of stormwater that otherwise would have gone into the sewers. And I've been by it on a rainy day, and on one side of the street with the old asphalt lot, you see all these puddles, and on the side with the permeable surface, it looks dry. Our agency, and I should mention this, is trotting out a watershed management ordinance for suburban Cook County. It will not apply to the city of Chicago, but it will set some minimum standards across suburban Cook County for stormwater management, and some thresholds in which any development or redevelopment of a certain size will have to capture some of that water on site, will have to have a release rate into the streams. It seeks to protect water quality. You can take a look at that ordinance on our website, which is mwrd.org. And we have a public comment period through December 31st and a series of public meetings that we're holding in suburban Cook County. Please weigh in on this. We need your help. Many of the mayors from some of the south suburbs in particular are worried that if we set even these minimum standards, it will kill development. That's not true. There are ways to develop and capture stormwater, but we need these countervailing voices from the conservation community and anyone else to make sure we get a good ordinance on the book. So both local municipal ordinances and any municipality can set more stringent standards, and some already have, for how you manage stormwater in your community. But I think it's got to be a culture shift, too, that we we start talking about drinking water management and not stormwater or wastewater. Well, I'm an elected official sitting on a board of 9 commissioners of this agency called the Water Reclamation District. And we oversee wastewater treatment and stormwater management for all of Cook County. I'm sorry, I can't hear you very well. What's my gut instinct for that? Oh, I see a lot of change coming. It's hard, it's slow, but you know, we are enormously fortunate to live right next to this wonderful freshwater resource. And I think the eyes of the world and of the nation are going to be on us, those of us who have access to Great Lakes water, and they'll be saying, are you being wise stewards of this precious resource, or are you being wasteful?
Debra, why don't we take one more question?
Okay. Another question? Oh, sure.
Perhaps in this forum, one of the ways that we can contribute is by thinking of ways of bioremediation, using nature itself to mediate. You are doing something different that doesn't exist beforehand, but you're nonetheless using thoughtful science to manage. I know as we go around the area, we see examples of bioremediation being put into practice, the oxygenation of the channels and using water flow itself. When you're talking about UV light, I mean, there must be lots of UV rays and cosmic rays we could make use of as well. So there are ways in science to approach some of these things that are like a halfway house between intervention and presenting a problem that could cure a problem.
Well, one of the analogies I've been thinking about lately in terms of our sanitation system is we currently use potable water as a wheelbarrow to transport waste. You know, we take it out of the lake, we run it through a water filtration plant, we treat it with chemicals, we use energy to send it out through a complex system of pipes to our homes, where it goes into our toilet waiting for us to deliver a load of waste that we then convey to a treatment plant. So the innovations of the future are going to be finding ways to use gray water, the water from our dishwashers, our laundries, our showers, to flush our toilets, etc.
I have a question.
Yes, sir.
Sensible?
No. Get rid of it. Use a reusable water container. You see, I brought mine. 30 million plastic bottles a day end up in landfill. The more water we can conserve, the more energy we conserve. It's called the water energy nexus. Chicago's tap water is excellent, and this is something we can model for our families, our children. Just stop buying it.
That's my feeling, too.
Okay.
I'd like to recognize Lance Grandy, one of our directors, vice president at the Field Museum. Kay Torsion, one of our directors who is president of Torsion Capital Management. Debra, this was a denouement, the whole thing.
Yes, indeed. Thank you.
But
Thank you
very
all.
much. Debra, would you be willing?